So at the top section of your notes for today, we want to think about some identifying features about each conic section. So if you're looking at like your standard form for your circles, what's going to be going on anytime you've got a circle? If you're just looking at the equation, how can you look at the equation and tell that it's going to give you a circle? X and y are both squared, but if x and y are both squared for ellipses and hyperbolas also. So what's the difference when it's a circle? It's going to equal to a radius, but how do we know that you can't just divide by that number and then end up with ellipses or whatever? It's not over anything. So what's typically going to happen is you're going to be given a function in a big long standard form or general form like this. And you've got to look at it and tell what type of conic section you're going to get from that. So if we have the same number or no number under these, that means you're going to have the same number in front of your x squared and y squared, because when you divide it off, then nothing's going to be left over. Does that make any sense? Whereas like with these guys, when we divided off whatever to get 1, we still had numbers left on the bottom, and that's what gives you an ellipse or a hyperbola instead. Does that make any sense? So for circles, we're going to say that you're going to have x squared and y squared. And your x squared and y squared are going to have the same coefficient. So that's your number in front is going to be the same on both of those. So how can we tell if it's going to be a parabola? Just one of them squared, right? So you either have an x squared or a y squared, but not both. So however you want to write that so that makes sense for you, I'm just going to say x squared or y squared. If you just want to say one of them is squared, whatever's going to make sense for either. Then what about ellipses, or ellipses, how do we say that? How can we tell if it's going to be an ellipse? Is it going to have both x and y squared? Yeah, so you can do that. So x and y are both squared. And then what's the main difference between ellipse and hyperbolas? Adding or subtracting, right? So with an ellipse, both coefficients are going to be positive. What can we write for hyperbolas? One of them is going to be negative, yeah? So both of those have both x and y squared. So positive coefficient.
They both be negative.
It's probably not going to happen unless like your whole function was negative. I mean, I guess that could happen. I'm going to say positive different coefficients. Because if those coefficients are both positive but they're the same, then it's going to be a circle. So if those are different numbers and they're positive, then it's going to give you an ellipse. So same idea for your hyperbolas. If they're different numbers but one of them is negative, that's going to give you a hyperbola. So I'm just going to write one of them is negative. Is that okay? So it's kind of just common sense, I think. You're just looking at them to see what it's going to be. So for this first section, we are just going to tell what type of conic it is. So for number 1, what do y'all think that's going to be? Circle, right? Because they're x and y are both squared and you got the same number in front. So that's a circle. What about number 2? That's another circle. Number 3. That one's an ellipse because you've got different numbers with the x squared and y squared, but they're adding. What about number 4? parabola. How do you know? Only one of them is squared, exactly. And what about number 5? Another parabola. And number 6? If it's got a minus, what's going on? Parabola. Number 7? Another parabola. And number 8? You got x squared and y squared. Do they have the same number in front? This is 1 over 25. So they don't have the same number in front, and they're adding, so what's that going to make? Ellipse. Okay? Questions on any of those? So, for the next sections, we're going to have to get those equations in their standard form based on what type of conic section it's going to be. So they're going to be a little bit different. And I don't want to do all of these with you because it gets to be a little bit redundant. So we'll just pick a couple on the front to do, and then we'll do like one from the back. So which ones do y'all want to do? Is there like one type of conic section that you know you're not as good at as far as getting it into? We're not good at parabolas. Okay, so let's find one of these that might be a parabola. Which one do you think? This first one, is this one going to be a parabola? How can we tell? Only one of them is squared, so we'll go ahead and go with that one. So if we want to get, we know it's going to be a parabola, we can go ahead and write that. P-A-R-A-B-O-L-A. And we want to get it in its standard form. So what do we need to do? Well, if you look back at our standard forms for quadratics, then we have like x squared, so it's going to be like this one. So you've got the x squared stuff on one side and everything else is on the other side, right? So we can move that stuff, and then how are we going to get it to look like this? What do you have to do? Complete the square, right? That's what you got to do for like all of these, everything. So I'm going to go ahead and pull out a negative because we don't want a negative in front there. So you would have like x squared minus 10x, and then we'll add something in to complete the square. What would we have to add? 25 equals, then I'm going to move the other stuff over, so we'll have negative y plus 21, and then we're adding a negative 25 for completing the square. Yeah? Questions there? Are we all right so far? Yes, because it was positive here, so we move it over, it's got to be negative. So when you factor the x stuff out, what do you get? X minus 5 all squared. And then we'll have negative y, and 21 minus 25 gives you negative 4. Because we had a negative out front of the parentheses. So, yeah, you have to take that into consideration. So the last thing that I would do there, what do y'all think? I would divide by negative 1 just because that's going to make it look a little bit nicer. So we can have x minus 5 all squared equals y plus 4. And that's it. Is that okay? Questions? Alrighty, so do y'all want to do another parabola, or do you want to try a different type of conic? Different one? So do y'all want to do 12, 13, or 15? 12? Okay, we'll do 12. So looking at 12, what type of conic section do y'all think that's going to be? Circle, right? Because you got x squared and y squared. Are the number in front of x squared and y squared the same? Yes, that's going to give you a circle. So we're going to have to complete the squared with the x's and the y's separately. So I'm going to get my x's together, the y's together, and we'll go from there. So we've got x squared plus 6x, and what would we have to add to complete the square there? 9. Then we're going to have our y's, so that's y squared minus 2y. What do you have to add to complete the square there? So I'm going to move that negative on over. I need to pass. Okay, I'll get it when you come back then. I'm moving that 9 over from here, and then we have to add a 9 from here and add a 1 from here. So the 9's cancel and we're just left with 1 on that side. Is that okay? Okay. So from the x's, what is that going to factor into? X plus 3 all squared. And for the y's? Y minus 1 all squared equals 1. And that's it. Is that okay? Do we need to do any more together? So we're good on the rest? Okay. So let's move over to the back. So for these, it's the same thing, but it's going to take it just a little bit further. It's going to have you graph it and then analyze it. So when it says analyze, that usually wants you to find like your center, your focus, your directrix. It just depends on like what type of conic it is, what you have to find. So if you're not quite sure, you can look back in your notes now. I help you figure out what you need there. So we got one of each here. What do y'all want to do? Pick a number, any number. 19? What would y'all rather, what type of conic would y'all want to do? Doesn't matter. I know that parabolas were like hard for us, so do we want to do parabola or do you want to try that on your own? We want to do parabola? Yeah? Okay, so that's 17, so we'll do that one. So just by looking at it, we can tell it's a parabola y. Just y squared. So we want to start getting that in our standard form. So what are we going to have to do? Yeah, we can get our y's together and then pull out a -2 from there. So -2, we'll have y squared plus 2y. And what do we have to add to complete the square? Plus 1. Then I'm going to move all the other stuff to the other side. So that's going to give us a -x and a -1 there. And what do we have to add to balance out the one that we added in? Why is it a -2? Because the front number, right, it was -2 times 1. So make sure we're putting a -2 on the other side. So then, when we factor out all the y stuff, what do you get? Y plus 1 all squared equals -x minus 3. So what can we do from there? Divide by -2. So that's going to give you y plus 1 all squared equals, I'm going to put the 1/2 out front and make it x plus 3 inside parentheses. Because that's more like our standard form, right? Where they've got, I'm going to pull the bell ringer down. It looks more like this. Does that make sense? Instead of dividing everything by 2. So that's why I did that. And that's it. That's basically as far as we can get, right? Okay, so we need to start graphing this. So where is your vertex going to be? -3, -1. So we can plot that. -3, -1. Well, for a parabola, it is like, it's your center, but it's the vertex on a parabola. Does that make any sense? So for like all the other stuff, it's your center. But just because the parabola is a different shape. Yeah. They're also going to want your focus and your directrix for this. So I'm going to go ahead and write that, and then we'll find it in a second. So how are we going to go about finding those two things? What do you need? A, right? And how do you get A? So let's look back at our standard form here. We got y squared. So we're looking at this. So we know that A happens right in front of the parentheses. So 4A equals what for us? 1/2. I'm pointing, you can even see. But does that make sense? Do y'all kind of see where we have the 1/2 where the floor A is supposed to be? So I would just write floor A equals 1/2 and solve for A. So floor A equals 1/2. So what does A equal? It's 1/2 divided by 4. 1/8. So, we've got that A value, so you know you're going to either add or subtract from your vertex to get your focus and directrix, and it kind of just depends on which direction you open, right? So, is this parabola going to open left, right, up, down? Which way? Well, we got y squared, right?
Right.
So that means it's either left or right. So does it open left or right? Why does it open right? Because you got positives in here, right? Because we divided off that negative. So we know that it's going to open this direction. So our focus is going to be inside. So we want to add 1/8 to the x value of your vertex. Does that make any sense? Because we want it to come inside your curve. So what's -3 plus 1/8? Well, it's 8 times 3. 24, so that's -24 over 8 plus 1 over 8. So -23 over 8. Yeah? So then for your directrix, we would subtract it because it's going to be outside behind your parabola. So -24 over 8 minus 1 over 8, -25. Is that okay? So now that's like super, super tiny, so I'm not going to worry about graphing that on our graph. If you want to sketch it and you can. But on your test, they're not going to put those on there, so you shouldn't have to worry about that. I don't think they will anyway. So we need to get at least 2 more points so we can sketch our curve. We know it's going to open to the right, but we don't have good points, so we need to find those. So that's where we're thinking, like, okay, what number can we plug in here that when we divide it by 2, it's going to have something that you could take the square root of? Does that make sense? Yeah. So, 4, if we did 4 plus 3, that gives you 7. Half of 7 you can't take the square root of. We want to end up with 4 over here. So half of what is 4? 8. So 3 plus what gives you 8? 5. So if we plug in a 5 for x, that's going to give us something that will come out nicely. Does that make sense? Okay. So we'll say that y plus 1 all squared equals 1/2 times 5 plus 3. So we already said that 5 plus 3 is 8, and half of that is 4, so the whole thing is supposed to equal 4. So y plus 1 all squared equals 4. Then we'll square root both sides. So y plus 1 equals plus or minus 2. So then we're saying y equals -1 plus or minus 2. So what is -1 plus 2? -1 plus 2, 1, and then -1 minus 2, -3. So when x is 5, we're going to have the point 1 and -3. So when x is 5, we're going to have 1 and -3. So those are your 2 good points. Connect your dots, and we'll have our parabola, and we're all done. Questions? Anything we're not sure about, don't understand? So, do we need to do another one together? Okay. Okay, because it's just more of the same, basically. So, I would like to go through and say what they're going to be and then write what you need to find. So, like for 18, what type of conic is this going to be? Well, we've got both x squared and y squared, right? They're not the same number, so we know it's not a circle. And they're not both positive. So what does that mean? Hyperbola. So for that, you're going to need to find your center, your vertices, and your focus, or foci, because there's more than one. For 19, what type of conic is that going to be? Circle, because you got x squared and y squared, and you have the same coefficient there. So that's a circle. So you're going to need your center, and we'll just do the radius, and that'll be enough on that one. Because that's basically all you need to grab it, right? And then for the last one, for 20, what's that going to be? Ellipse. So we'll need your center there again. And then we'll need the vertices and the focus again. We all right to do the rest of our own? Yeah? Okay. So you're doing those 3 on the back, and then we're finishing up the ones that we didn't do on the front. So yeah, I'll just give you, y'all can do that in partners. Doesn't really matter. We can go over it once everybody's time to work on it. Does that sound good?